Now, let us understand the interconversion of the states of matter on the basis of kinetic molecular theory. Matter can change from one form to other form, that is from solids to liquids and liquids to gases. Gases can be converted to liquids and liquids can be converted back to solids. The phenomena of the change of matter from one state to another and back to original state, this is known as interconversion of the states of matter, which is done by changing temperature or pressure. Let's start with the conversion of solid to liquid. When a solid is heated, its internal kinetic energy increases and the particles vibrate. These particles of the molecule, they start vibrating very fast about their mean position. This weakens the force of attraction between them and molecules move away from each other, resulting in a liquid state. Now this phenomena known as melting. When the solid is melted, it converts to liquid. Now the heat which is provided to convert a tightly bound solid to a loosely bound liquid is called the latent heat of fusion. I repeat again, latent heat of fusion, the heat which is required to convert a tightly bound solid to a loosely bound liquid is known as latent heat of fusion. Now, when more heat is applied to the molecules of the liquid, they gain more kinetic energy. As a result, the number of molecules escaping from the surface increases. Eventually, at a temperature called boiling point, the atoms have enough energy to escape from the liquid. This phenomena is known as vaporization, and the liquid changes to vapor state. The heat which is required to convert a loosely bound liquid to a freely moving gas is called the latent heat of vaporization. This is known as latent heat of vaporization. The heat required to convert a loosely bound liquid to a freely moving gas is called latent heat of vaporization. Now let us understand the conversion of gas to liquid. Gas, when cooled down, the heat is removed from it and the molecules lose their energy, resulting in less number of collisions. Hence, gas condenses to form liquid. Now, what is condensation? The condensation is the conversion of vapor state to liquid state on cooling. When liquid is further cooled down, it changes to solid state. Now, conversion of liquid to solid on cooling is known as freezing. Few solids, they directly change into vapor form without getting into the liquid state. So this direct conversion of solid to vapor form is known as sublimation. And vapors directly get back into the solid form. This is known as opposite of sublimation, that is desublimation. So I hope the interconversion of states of matter on the basis of kinetic molecular theory is clear now. Now let us understand the difference between gas and vapor. Gas is a substance that remains in the gaseous state under normal conditions of room temperature and atmospheric pressure. We can say that the natural state of matter for a gas is a gas. Examples: oxygen gas, hydrogen, nitrogen, etc. They are gas at normal conditions of room temperature and atmospheric pressure. So gas is a state of matter. This is a state of matter. But vapor, is vapor same as gas? No. Vapor is a substance that is solid or liquid under normal conditions of room temperature and pressure, but changes to gaseous state on heating, or under special conditions of temperature and pressure, it changes to vapor state. So we can say that this vapor is formed by a substance which is either solid or liquid under normal room temperature and pressure. For example, water vapor, iodine vapor. Now water vapor is a vapor which has been obtained by heating water. Water is a liquid state of matter at room temperature and pressure. So from water it has changed to water vapor by heating. Iodine vapor, we know iodine is solid at room temperature and pressure. So when we change the temperature of the iodine solid, then it changes into iodine vapor. Second point in gas is it is a substance which exists in the gaseous state at a temperature equal to or more than the boiling point of its liquid state. Let's take an example. Nitrogen gas is at room temperature and it would still be in a gaseous state. So here in vapor, it is a substance which exists in the gaseous state at a temperature which is lower than that of boiling point of its liquid state. Let's take an example. Steam or water vapor would be a vapor because at room temperature it would be water which is a liquid. Let's discuss few uses of interconversion of matter, or what are the benefits of change of state of matter in our daily life. First, the steam is used to run turbines and to generate electricity. How is steam produced? When water is changed into water vapor, when liquid state has changed into vapor state. Next point, water can be changed into water vapor as well as ice. Water when heated changes to water vapor which is present in the atmosphere, as well as water when it freezes or cools down, it changes to ice. Therefore, we have natural ice like snow, liquid water in the water bodies, drinking water, etc., and water vapor are available. Third point, for the artificial respiration, liquid oxygen is used. How liquid oxygen is formed? By the liquefaction of the oxygen gas. Students, liquefaction is a process of conversion to the liquids, converting to liquid. So, when the oxygen gas is converted to a liquid oxygen, then it is known as liquefaction. Now, this liquid oxygen can be used in the artificial respiration. At home, in the domestic cooking, at home, we are using LPG, liquefied petroleum gas, while cooking the food. Why it is liquefied? It is liquefied to help in the transportation of the LPGs to various places. And this is done by the process of liquefaction, means the process of conversion to liquid state. The naphthalene balls are used for protecting the woolen clothes from insects, and room fresheners are based on the property of the sublimation of substances. Now, room fresheners and naphthalene balls, they are the sublimate solids, and with the help of these naphthalene balls, we can get rid of the insects from the woolen clothes, and with the help of room fresheners, we can get rid of the smell also. Students, in my next video, we will understand the law of conservation of mass with numericals. Thank you and have a nice day.